AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Our host brings you the leading minds in AI, sharing their story, their success, and their advice. Focusing on fast-tracking you to the top, AI in Action cuts through the hype to help you kickstart your data science career. To listen to the latest AI in Action podcast, head over to www.alldus.com/podcast or subscribe via iTunes, Stitcher, or Google Podcasts.
You're listening to AI in Action. I'm your host, JP Valentine. Our guest today is Charles Taylor. Charles is the founder and CTO at HeartFlow. Charles, welcome to the show.
Yeah, thanks, JP. Great to be on it.
So, Charlie, let's start with a background of yourself. Can you walk us through your journey? A little bit of an overview of what your journey in technology has been, where you started out, what got you interested, and take us up to today as the founder and CTO at HeartFlow.
Yeah, I'll first start a little bit, if you don't mind. I'll go back why I got interested in engineering and technology. I guess I was pretty good at math when I was younger and I always enjoyed that. But in the area where I grew up in upstate New York and in a town, both my grandparents were textile workers and factory workers. And I actually, as a teenager, got a job working in a textile factory, actually one of the last ones in the area that was still running. And first of all, it taught me about obviously the value of hard work, but also how much I wanted to use my brain and go forward and use some of the skills that I had in mathematics and science. And I was just always fascinated by this. But the big transition for me, I'd never touched a computer till I got to college and started to then learn in programming in Pascal and Fortran and C, and then ultimately many other languages. But what was exciting for me is when I was a junior in college, I was at Rensselaer. They had a co-op assignment, and I was originally going to work at this chemical manufacturing plant, and it would be an interesting job, but somehow at the last minute, it got switched where I was going to be working in this advanced design engineering group at GE, where I was going to be using computers to design products. And this is, many years ago, almost 30 years ago. And it was just at the dawn of that era of really using computer technology in a lot of different ways. And so I was just fascinated by that, about how you could teach a computer to ultimately program a computer to model the physical world. It was fascinating to me. I ended up then going to work at GE and got more and more interested in this, took all the courses I could, got a master's degree in engineering and then also a master's degree in mathematics because I wanted to understand what was behind the algorithms, and then decided to go on for my doctorate. Went to Stanford for my doctorate in engineering, and I was there actually working on using computer models of different problems, mostly looking at fluid flow over airplanes. And happened to see a flyer for a talk. I remember exactly what it was called. It was called Blood Flow in Your Health. I remember where I was when I saw this, and this is back in 1993. And it was a talk by a new head of vascular surgery, and he had been doing this experimental work to understand blood flow in arteries. And I had been doing all this computer modeling and learning these techniques for understanding how to use computers to understand different problems, and met him. I started working on this together with a very prominent engineer, applied mathematician, computational scientist named Tom Hughes. And then the three of us started to apply computers to understand blood flow in arteries. I spent time basically building software systems, and my team built software systems to understand blood flow in arteries, and did that for 14 years on the faculty at Stanford, but wanted to take this out. I was the first one to do computer analysis from medical image data to simulate blood flow in arteries. And I realized that had tremendous clinical benefit, clinical applications. We could predict how something was working in a patient's arteries and in their body, and then use this information to improve treatment procedures, to develop better treatments, design procedures on a computer that physicians could then implement in actual practice. So that was a little background preceding the formation of this company, HeartFlow, that I founded with Chris Zarens, who was the chief of vascular surgery at Stanford. I was a professor of bioengineering and surgery. And also together with John Stevens, who's a former cardiac surgeon and entrepreneur. So the three of us got HeartFlow going and started to build technology to do computer analysis of blood flow in the heart, in the arteries, providing the blood supply to the heart. And that's how we got started.
Yeah, great background and really speaks to the idea behind HeartFlow, the formation and the mission behind the business. So you launched the company almost 14 years ago now. So can you give us some insight into when you first decided to launch the business? What was the
Yeah,
objective? How has that evolved over time? And sort of walk us through the journey over the past 14 years.
yeah. Yeah, so HeartFlow, we started off as a company that was previously called CV Sim, or cardiovascular simulation. We formed HeartFlow in 2010 and using some of the technology from this CV Sim, but really the direction that we went into was to build actually a diagnostic test, a non-invasive diagnostic test. And the storyline was that to get the most precise, most accurate information about that was needed to understand how to treat a patient with heart disease, typically you had to take this patient into a room called a cardiac catheterization lab, where this is a procedural room where physicians are basically puncturing, inserting a catheter into the groin or into the arm, into your artery, and then snaking this up into the heart, into the arteries providing the blood supply to the heart, the coronary arteries. And then, for instance, injecting a dye to get a picture of inside of the coronary arteries, or to have other techniques like put pressure wires in there to measure conditions in the coronary arteries. This is it sounds and it is a very invasive procedure to be able to get this type of information. But it was the kind of the gold standard. It was the most precise, most accurate information you could get for a patient. The non-invasive tests, like imaging tests, they're non-invasive. It was great. You didn't have to do all of that, but it didn't have the same level of information, the fidelity of information. So what we set out to do was to basically get the benefits of a non-invasive test, a fully non-invasive test, but with the accuracy of the gold standard, the invasive procedures. So how we did this is we used medical imaging techniques to see the arteries that provide the blood to the heart, the coronary arteries. We imaged those with a technique called coronary CT angiography, injecting not a dye directly into the coronary arteries, but into a vein in your arm, where you could inject contrast and then image using a non-invasive technique like CT, image the arteries. What we had to do then is to extract the information about the arteries from the image data, use computer vision techniques, and this is where the AI comes in, to extract very accurately the anatomy of the coronary arteries. And then we use computers to simulate blood flow. So we were predicting flow and pressure that we then compared against these invasive measurements with pressure wires. And what we were able to prove is that we could do this very accurately, and that the tremendous benefit to patients is that before you'd take 100 patients to the cardiac catheterization lab and you'd only find 25% of them would be patients who really needed to be there or could be treated with an invasive procedure. Whereas with our test, we find the ones that really don't need to be, again, an invasive test or an invasive procedure, but can be treated with medicine. So the patients the ones who really need a more aggressive therapy get it, but the ones who can be managed more simply with medicine can get that as well. But it's all really dependent upon extracting information about the heart and about the coronary arteries from imaging, using artificial intelligence methods to basically determine where the inside of the blood vessels are, where the disease is, really computer vision techniques, and then using computer simulation, the simulation of blood flow that's done in the cloud to provide this information back to doctors.
Amazing. And I think hearing that description, it's hard to think of a more powerful example of how AI and technology is going to impact healthcare for good, because the advancement from where it was traditionally to where you've taken it already is very significant indeed. I would love to now spend a bit of time talking about the technology behind it all. Just right, look, as your role as CTO, you oversee everything, but you've already touched on the components that are happening to get to this stage with computer vision and visualization and so on. Could you give us some insight into the current makeup of the tech and the data team behind the scenes and what it's like to be part of that group?
So I'll tell you a little bit about how does the data come to HeartFlow, and then what was done before. People would build technology, they developed technology to visualize, to look at the heart, to look at the image data, and they would put it on a workstation, a computer, and they would put it into the hospital, behind the hospital firewall, etc. And that would be running there, and the doctors or usually technicians or technologists would use this software on the hospital site. They would have to learn how to do it, how to use the procedures, et cetera. But typically the data never left the hospital. So whatever they learned on site, that learning was basically constrained within the walls of that institution. And how we set up our business was very different. And what we recognized early on is that, first of all, it just wasn't practical to be able to do that. Advanced technology, wasn't practical to run it all on the clinical site. So what we had to do is we had to develop software. It's called HeartFlow Connect, that is installed in the healthcare system, that basically serves as a way to route the patient data out of the hospital into our application that runs in the cloud. HeartFlow's software runs in Amazon Web Services. We take data out from hospitals all around the world. We de-identify it. We separate the patient identifiers from the raw image data, and we store the patient identifiers in region, and then we take the image data, and then it comes into our application run in Amazon. So the first thing that happens is we have an automated pipeline, in a deep learning based pipeline, to be able to take the image data set, and it's just a collection of voxels, three-dimensional pixels with a grayscale information about the heart. So it doesn't jump out at you and say, here's the heart, here are the coronary arteries. You got to extract it, pull that out of the images. So if you think about facial recognition techniques for 2D pictures, et cetera, so this is in 3D. And you have to extract the 3D geometry of the heart, of the chambers of the heart and the coronary arteries, with a level of precision that is in a fraction of a millimeter or so on that scale. So it's incredibly important to do it accurately, precise, et cetera. What you don't want to do is to miss a area of disease. That's not tolerated. You have to be able to do this very precisely. So we have an automated pipeline that runs our AI algorithms to be able to create automatically a 3D model of the patient's heart and coronary arteries. What's unique about what we do from there is that we take that model from Amazon, from the cloud, we pull it down into what we call a production facility, where we have people that sit in front of computers. These are our analysts, and they're trained to use our software, visualization software, to look at the AI created model in the context of the image data. And then what they do is they inspect and they correct. And this is critically important. So this is what we do as human in the loop AI. And they basically steer the algorithm. They correct the algorithm along the way. And once that correction that they have for that single patient is then used, for our blood flow simulations to provide results back. But what's really important is that those corrections for thousands of patients can be aggregated and can be put back into the deep learning pipeline, where we have the automated algorithm that has then been inspected and corrected by trained analysts, and those corrections go back into the algorithm. So it's the analogy with the driverless car, where you have people in the driverless cars that are in there basically teaching the computers how to drive, but we're basically teaching the algorithms how to interpret data and interpret medical image data along the way. Again, the human in the loop AI. And then what we've been able to demonstrate and prove is that eventually you get so good, and the AI algorithms get so good, that there's very less and less need for correction. So imagine that the driverless vehicle gets better and better, so you can trust and rely on it more and more. There's actually a pretty good analogy there. Our team, to get back to your original question, we have elite AI scientists, deep learning experts. We're building absolutely customized algorithms to really go after this particular problem we're solving. We have data scientists that work together with them, because we're training on data from thousands, tens of thousands of patients right now, and ultimately this will be millions. And of course, a back-end team, a front-end team, our DevOps team, computer vision experts that build the visualization software, testers, et cetera. So it's a pretty diverse tech stack, from deep learning in the cloud, big data, the data science work as well.
So you've given a great overview of the various different skill sets and roles that you have at HeartFlow. You've obviously scaled the business over the last 14 or so years, many challenges throughout that time, most recently with the pandemic. When you look back, what have you learned about the challenges of building and scaling a team, but also if you were doing it again, what would be the things you would focus on and double down on to be successful in hiring, building a team?
So first of all, some of the things that I feel like we've done well, and I'll just tell you some of the things that I'm really proud of, is that as we've done this, it's always been about the patient first, about how do we drive quality. And I always say we have a maniacal devotion to quality and the quality of the result because it matters. If we provide a result back to a physician, we want them to trust them. I always tell my team, they've heard it, they're so sick and tired of hearing me say it, but it's that Dutch proverb. I always tell them that trust comes in on foot and leaves on horseback. And you're building a company like ours in healthcare where the doctor needs to know that they're going to make a life and death decision for a patient. It's so critically important, the information we're providing them. And it's about trust. Some of our physicians, one of them I really like, said to me once, he said, Charlie, your team, your AI finds a lot of things that I miss, but you're not allowed to miss anything I find. So they have this incredibly high expectation. Just to give you an example, some of the non-invasive cardiac tests that are used, physicians call them coin flip tests because they don't trust them. They think of them as about as good as a coin flip. But our expectations of our customers is that it's like the AI, our methods, they got to be right all the time. Of course, nothing is perfect. No test is perfect, but very high standards and high expectations. But to answer your question, the first thing I'm most proud of is this maniacal, pursuit of quality and about driving that and always trying to make the best decisions that we think will enable us to deliver the best product to our customers and that will have the highest clinical performance and quality. The other thing I would say I'm proud of is that along this journey, we've been pretty open about what we've done. We have a lot of proprietary methods and our deep learning methods, but a lot of the other things that we do, we're pretty open with the medical community about. There's been hundreds and hundreds of medical journal papers published on our technology, on the results of our tests, et cetera, and we've leaned in really heavily to data, into evidence and proof, because we're not gonna provide something that we won't stand behind, and that we won't, if there's a question about it and about how it works or does it to apply to a patient population, we're going to go dig into it and find it out. So I'm very proud of that. I would say that from lessons learned, it's damned hard. It's difficult. I don't think many people who start companies, they don't last. Most startups don't make it, don't survive. And we've very well capitalized, well funded company. We're thriving. We're doing very well in a very hard problem, tackling the leading cause of death, the heart disease. And, I just think that probably the most important lesson is that things are gonna, as the expression goes, shit happens. Pardon my French.
Yeah, no, you're absolutely right. I think it's great to hear just an honest, raw assessment of how difficult it can be.
Yeah, and you just got to be resilient. I would say from an organizational perspective is the most important thing is like, how do you get the best people you can get working with you? And that's a tremendous amount of fun when you have a great team. But then how do you figure out how to build resilience in the team? And how do you keep people motivated over a long journey? In healthcare, it's not like a tech startup company where a year or two later you got a product and you're public and you're bought by a big tech giant, for instance. It's not this kind of company that we're building. And especially in healthcare, it is a long journey. And it's regulatory issues, there's payment issues with insurance companies, it's complex, our healthcare system. But when you can produce a technology and a product like I feel that we have at HeartFlow that can have a tremendous impact, it's so rewarding. I've had many patients come up to me afterwards that have had our test, and they're sometimes teared up and they say, your test might have saved my life. And that's just priceless.
That really stands out because as you start talking about the resilience required to get through a startup, having belief in the mission would get you through a lot, because it helps people work through those difficult days, and it also helps define the culture. If you can hire people who are on board with the mission, they'll work through those difficult times. Right. So looking ahead now, look, obviously, Charlie, an incredible journey so far. You guys have achieved so much in the last 14 years. When you look ahead, what are you most excited about?
Yeah, I think, first of all, when we started, and I will have to tell you that in the very early days of HeartFlow, we had computer vision algorithms. We were started to use machine learning methods almost 10 years ago. but we've really started to push into deep learning area. We've now in our FDA approved product, cleared product, we've had deep learning methods in that product for more than 4 years now. What's really exciting to me is the possibilities as we move forward. And our team is now doing this amazing work to extract information about the plaque or the atherosclerosis in coronary arteries using really fully automated deep learning based methods. And it's so exciting to see that. But I'm just blown away by this possibility. At first, you think about AI and your standard is you want it to be as good as your human driver or your human reader. But I think that's setting the bar too low, quite frankly. I think in healthcare and medicine, it is absolutely transformational. One of the physicians that I had talked about this, before with me said the readers or radiologists, that the AI is not going to replace the radiologist, but radiologists that use AI will replace those that don't. And I think that's absolutely correct. I heard a similar expression from a healthcare system, a hospital, where they thought that hospitals that use AI will replace those that don't. This is a monumental change, obviously in technology in the world, but in healthcare. And that's one of the things that is incredibly exciting to me, is that being able to start to leverage the power of these methods, but also to apply it to more and more information data. We have right now in our data repository, I think data from more than 80,000 patients. And as this continues to grow, I feel like we're going to be able to extract information, extract insights about heart disease that are just completely impossible with prior methods where you're looking at a one-off case or doing small studies. I think that the insight we're going to gain into healthcare, into diseases, my team, what we talk about is how heart disease is the leading cause of death in the developed world. And most developing nations, eventually they solve the other diseases in developing nations, and heart disease becomes the leading killer there. And it shouldn't be. It's a disease that is manageable, that is preventable. And if we can provide better information about patients, about their heart health, then we think that we, together with, of course, the other companies that are working in this area, in our lifetimes could, see heart disease lose this status and knock it down a few notches. That's exciting to be able to do that, to be able to develop technology as cool technology that can have a massive impact on individual patients, but also on society as a whole.
I think that's the best way to finish this interview. You've given an absolutely amazing representation of HeartFlow. It sounds like a fascinating place to work for anyone who's interested in this technology, data science, data engineering, machine learning, computer vision, everything that's involved in getting the product to market, and obviously exciting growth ahead. So thank you again, Charlie, for coming on and talking to us. We really appreciate it.
Yeah, thank you, JP. It's been my pleasure.
AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Alldus offer an exec search program. Alldus can help you discover how data science and AI can transform your company. With our unrivaled network of C-suite executives and senior AI professionals, we offer retained search services across the US and Europe. Get the Alldus advantage. Become a member of the Alldus community and enjoy some of the following: AI meetups. Once a month, our community gathers to listen to some of the leading experts in the world of data science and AI. Our speakers come from all over the world, including Dublin, Boston, and Frankfurt. We also have our AI mentors. Our experts will provide mentoring to Alldus members. And don't forget our AI in Action podcast. Each week we have guests from all over the world talking us through their education, career, and more. Become an Alldus member and get the Alldus advantage. For more information and to sign up for our newsletter, log on to www.alldus.com. That's www.alldus.com. Alldus International, empowering through AI.